So we get our p-value of 0.6995 times 10 to the negative fourth. Or 0.00069995, which is certainly less than our alpha of 0.01. So we reject the null hypothesis. And what that means for us, now we can write a conclusion. Our null hypothesis was that it was 10%. What we were trying to say, alternatively, is that it's more than 10%. So because we rejected the null hypothesis, that means that we do have statistical evidence that more than 10% of the population would be bothered by staying on the 13th floor. Okay. Okay, so let's look at another problem. Suppose we have this following sample. In this case, we're not going to look at any sort of context. We just have some raw numbers. So here's a list of 10 numbers. Find a confidence interval for the mean of the population. So what we're going to do is, since we have this numeric data and we have the actual data, we're going to start by entering the data into our calculator. Okay, so we're going to enter that into list L1. So I'm going to go to Stat, Edit, and there's L1, and you can see I've actually already entered that data. Okay. So now if I want to create a confidence interval for the mean, what I'm going to do is use stat tests and do a t-test. Now we did one of these a minute ago, but when we did it before, we had the statistics for the sample. This time we have the actual raw data. So when I do a t-test, I'm going to go over to data, and I'm going to, oops, I'm sorry, I'm jumping ahead of things. T-test is for hypothesis testing, and right now all we're going to do is confidence interval. So I'm going to go to number 8, T interval. Okay, and same idea, make sure that our input is data. The list that we entered in is list L1. Frequency should always be 1, and our confidence level is 0.9, and we can hit calculate, and there's our interval, 7.3096 to 11.69. Okay, so rather than do conclusions, because there's no context here, we're going to answer some different questions. If we increased the sample size, what effect would that have on the margin of error? You can think of the margin of error as being like a target. Okay, so if I have a target and I'm throwing darts, right, and there's the bullseye, the increasing the sample size would be like reducing the level of uncertainty, right? I'm getting more information. So what I can do, if I have a more sample size, I'm going to have more certainty. So what I can do is say, okay, I can be sure that I'm gonna hit a smaller target. Okay, so if I increase the sample size, my margin of error is going to decrease. Okay. Now, what if we increased the confidence level? Let's come back to this target idea. Suppose that I'm 90% sure that I can hit a target this big. Okay. If I'm the same person throwing darts or whatever we're doing and I want to hit a target, suppose I want to be 95% sure. Well, I'm the same person throwing. I want to give myself a bigger target if I'm going to be more certain. Okay, so if we're going to increase the confidence level, that would increase the margin of error. Okay, and that's counterintuitive. Increasing the confidence level, that doesn't make the margin of error smaller. Those two are separate things, and they both deal with uncertainty. So if I increase the confidence level, I have the same amount of uncertainty in my sample, so I make up for that by having more margin of error. On the other hand, if I reduce the confidence level, I'll have a smaller band for my estimate.